Yes, sir.
All right. 2017. So it is saying that, so let's start. Question 1. It says that P and Q are positive integers. So if P and Q are positive integers, it wants to know which of the following statements is true. So option 1, P is less than Q. If P is less than Q, then P minus 1 is definitely going to be less than P minus 1 is definitely going to be less than Q minus 1. That's true. So you can always give P and Q values. Let's let P be 1. 1 is less than 10. If you subtract 1 from both sides, we're saying that 0 is less than 9. So 3 is true. Now, it says minus P is greater than minus Q. Let's test that out. Minus 1 is greater than minus 10. It is true. Minus 1 is greater than minus 10. And so option I is also true. And so 1 and 3 is the answer. There is no option that has all 3 to be true. So C, option C. Now question 2. For some reason it looks a little bit dark for me. Let me try turn up the brightness. All right, that looks fine. Question 2. Question 2 says, if a remainder of 3 is obtained when 8x cubed plus 4x plus k is divided by x minus 1, then what is k? To find k, we need to use remainder theorem, and remainder theorem tells us that from this f of 1 is equal to 3. If f of 1 is equal to 3, we're solving 8 times 1 cube, which is 8, plus 4 times 1, which is 4, plus k is equal to 3. And so 8 plus 4 is 12, and we have 12 plus k is equal to 3. And so what we're obtaining is that k has to be equal to minus 9. So that's k, option B. Option B, nice. Nice and easy, soft. Now question 3, not options 3. Question 3. It says the expression, it is raining. Now I'm going to underline it is raining. It is raining is P. This right here is and. So P and. The sun is shining. The sun is shining. The sun is shining. That's option Q. So P and Q. And it says, but there is no rainbow. So this no stands for not. So that's a negation. And it says there's no rainbow. Rainbow is R. So what they're telling us is that P and Q, and not R. And not R. That's what they're telling us. They're telling us that it is raining and it is shining, but there is no rainbow. Right? Generally, when the rain is falling and the sun is shining, we see a rainbow. But in this case, rain is falling, the sun is shining, and there's no rainbow. Hence the use of the conjunction but. Question 4. Question 4 asks us to simplify this. So we have 4 root x plus, we're asked to simplify 4 times root 3. I'm just breaking up root 3x as root 3 times root x. And then the root of 48, we can break up 48 as 48 is 16 times 3. That's the root of 16 times the root of 3. Now, look at this now. The root of 3 is going to cancel the root of 3. 4 is going to cancel the root of 16. So what we're left back with is 4 root x plus the root of x, which is 5 root x. 5 root x. 5 root x, that is just option A. Easy question, soft. Question 5. Question 5 is asking us to rationalize this question. To rationalize it, we multiply by the conjugate of the denominator. And so what we're going to get is root 2 minus 1 times root 2 minus 1. Now when you multiply root 2 minus 1 times root 2 minus 1, you're going to get root 2 minus 1 all square over, and the denominator is just going to become the difference of 2 square, which is the root of 2 all square, which is 2, minus 1 all square, which is 1. So what we're getting is root 2 square is 2 minus 2 root 2 plus 1. 2 root 2 plus 1. So that's equal to 3 minus 2 root 2. 3 minus 2 root 2. That's option B. Another way to do this question is, let's say you don't have time to do all of this. You can put this in a calculator. You're going to get a decimal. And then look which one of these is going to give you the same exact decimal. That's another way to do it. So just put it in a calculator and see which of those give you the same decimal. Because we can use our calculators. Easy. Now this is asking, find the values of x to satisfy this equation. So for me, we have x minus p and x minus p. So first thing we can do is factor out x minus p, right? Can factor out x minus p. And what we're left back with is x minus p all square minus q square, and that's equal to 0. If we factor out x minus p times x minus p all square minus q square is equal to 0, then what we're saying is then is either, let me write it all the way down here. So question 6 is being continued in this space. What we're then saying is either x minus p is equal to 0, or we're saying that x minus p all square minus q square is equal to 0. That's what we're saying. So if x minus p is equal to 0, then x must be equal to p as one possible solution. Or, now this is a difference of 2 square. The difference of 2 square can be written as x minus p minus q times, in this case, it's going to be x minus p plus q. And both of those is equal to 0. And so from this part, what we're getting is that x must be equal to p plus q. And from this part, we're getting that x must be equal to p minus q. That's what we're getting right there. That is p plus q, p minus q. That's C. Now this question, question 7. Question 7 says the annual growth G of the population is in a country for X years is represented by 2 to the X. So it's represented by 2 to the X. So now it asks us, in how many years will the growth be 32,000? So what they're asking you is to solve the equation and solve when it is equal to 32 to find what value of x is going to make it be equal to 32. So we're solving 2 to the x equals 32. And so clearly x is going to be equal to 5 because 2 to the 5 is 32. So x is equal to 5. Nothing to do right there. Soft. All right. Question 8. Question 8 says, alpha and beta are the roots of the quadratic, and so find the value of alpha squared plus beta squared. Now, first and foremost, alpha squared plus beta squared, that's equal to alpha plus beta all squared minus 2 alpha beta. So it's equal to alpha plus beta all squared minus 2 alpha beta. Now, alpha plus beta is the sum, and alpha plus beta, that sum is equal to P, and alpha beta is equal to Q. So alpha plus beta is P squared minus 2 times alpha beta. Alpha beta is Q, and so it is P squared minus 2Q, which is C. Easy, soft. All right, question 9. Question 9 is asking, which of the following mapping diagrams does not represent a function? This is a repeat question that we did in the last paper, and we said that it was option D. It's a repeat question from 2016, where we looked at the vertical line test. And we said option D. That's a repeat question again. Nothing too bad right there. Question 10. Question 10 asks, what is this statement logically equivalent to? So the negation of, we're going to use distributive law to simplify inside this bracket. So it becomes P or not P, P or not P, P or not P, P or not P, and P or Q, P or Q. So that's what inside the bracket simplifies to be. Now look at this. P or not P. Think of P as a statement. I am hungry. Not P is a statement. I am not hungry. So it's either I am hungry or I am not hungry. So P or not P is always true. So that's a tautology. So that becomes a negation of true and P or Q. So that's what we end up with. Now, true and P or Q is just going to work out to be the negation of P or Q. And you're probably wondering, why is that so? Why is that so is, think about it. If P or Q is true, then you get true or true is true. But if P or Q is false, then you get true and false is false. And so the result is dependent on what is P or Q. So the negation of P or Q now is equivalent to not P. And then when you negate the and, when you negate the or, you get and. So you get not P and not Q. And so we're getting not P.
Wait, sir.
Repeat?
Sir.
Yes, go ahead.
Isn't that a conjunction symbol in a square bracket?
The
The
square
true.
bracket. This true and.
Yes, sir. But you said or.
Repeat?
A while ago you said true or P and or P or Q. You know.
Oh, I should say true and
Yes, sir.
P or Q. Thank you. True and P or Q. So true and P or Q is P or Q. So I should have said and. Thank you. And that's question 10. Question 11 now. Question 11 is asking us to find the range. So they give us the domain and ask us to find the range. So the domain is, let's write down the domain. The domain is that x is between -1 and 3. And then it wants to know what is the range. The range is where f of x is in between. F of x is going to be in between f of -1 and f of 3. That's what f of x is going to be between. That's the range. And so f of 3 is going to give me 3 squared. 27 minus 1 is 26. And then 1 cube is -1. Minus 1 cube is -1. Minus 1 is -2. -2. That's where f of x is between -2 and 26. So that's the option. That option is D. Option D. Easy, soft. That's the only option that has all the values between -2 and 26. Question 12. Question 12, it gives us that we have a cubic equation with roots alpha, beta, and gamma. It wants to find the value of alpha, beta, gamma, and beta, gamma. So what's the value of alpha, beta plus alpha, gamma plus beta, gamma? Well, first and foremost, we know sorry about that. So first and foremost, we know that alpha, beta plus alpha, gamma plus beta, gamma, we can find that out. So alpha, beta plus alpha, gamma plus beta, gamma. Alpha, beta plus alpha, gamma plus beta, gamma, that's equal to -5, right? But they don't want that. They want alpha, beta over 2 plus alpha, gamma over 2 plus beta, gamma over 2. So let's divide all of this by 2. One, if I do to one side, I do to the other. And so it is -5 over 2. That is C. Easy question. Soft. All right. Question 13. Question 13 asks us, what are the values of x that will satisfy this inequality? All right. So first thing, we need to get rid of the modulus. To get rid of the modulus, we have to square both sides. So we have 2x minus a all square, and that's greater than x squared. And so what we have now is when we square both sides, we're getting 4x squared minus 4xa plus a squared, and that's greater than x squared. That's greater than, oh, sorry about that. Why did I erase that? So what we had, let me just write down that step that we were at. 4x squared, because we had squared both sides, minus 4xa plus a squared, and we said that's greater than x squared. And so what we end up with now is when we bring over x squares to this side, we get 3x squared minus 4xa plus a squared is greater than 0. Now we just factorize factorizing it is we need to get 3x squared. So I'm just going to write 3x. I'm going to write x. I need a squared, so I'm going to write a and a. Then I'm just going to put minus and minus. That's only I'm going to get a negative here, but a plus also here. All right. So now right here, I want when this is greater than 0. So just going to look at a sketch. So let's say you have a sketch, a diagram sketch, right? Let's say this is the quadratic curve, right? It's a smile curve because a is greater than 0. And so this value is going to give us a over 3. That's x value right there. And this is going to give us a value of a. Now we want the value of the function when it is above, when it is greater than 0. This is the line y equals 0. And we want when it is above that, so we want all of these values. We want all of these values. So it's only going to be above, when x is going to be less than a over 3, or when from this side when x is greater than a. So for example, so that answer is a. You can try answers. For example, let's say x is equal to 2a. So this is a. 2a is greater than a. When x is equal to 2a, we get x is equal to 2a. We will get 2 times 2a, which is 4a. 4a minus a is 3a, and 3a is greater than 2a, clearly. So when x is greater than a, we see that it is true. Now, you can try a value for x when x is less than a over 3, and likewise, it's also going to be true. So A is the answer for question 13. Easy, soft. That's question 13. Question 14 is a repeat question that we did from the last paper, and that was 5. Repeat question. Easy. Question 15. Now, question 15 is asking us to find alpha plus beta plus gamma. Alpha plus beta plus gamma is minus b over a. So it is 4 over 3. So 4 over 3 is alpha plus beta plus gamma. And then alpha beta plus beta gamma plus gamma alpha is minus c over a, which is negative 7, which is 7 over 3. So that looks like option B. Easy question. Soft. Question 16. Question 16 says, find the value of the modulus of 3a plus 2b. So we want to find the modulus of 3a plus 2b. So first we need to work out what is 3 times a. 3 times minus 3, 7, plus 2 times b. Plus 2 times b, which is 2 times 2 minus 1. That's going to be working out to be equal to 3 times minus 3, that's minus 9. 3 times 7, that's 21. And we're going to add that to 2 plus 2 is 4. Then 2 times minus 1 is minus 2. And so the vector that we're getting looks to be 5 minus 19. But they want the modulus of this vector. They want the modulus. And so the modulus is going to be equal to 5 squared plus 19 squared square rooted. You can say minus 19 squared, but Either way, when you square a negative number, you get a positive number. 19 squared plus 5 squared, that's the root of 19 squared plus 5 squared, 386. That's the square root of 386, which is B, which is easy. Nice. Now this question, we're expanding this right here. So it's just going to be equal to the sine of 30, which is a half, times the cosine of A, cos A. Then we have minus the cosine of 30, which is root 3 over 2, times the sine of A. So we'll just use the compound angle formula to expand this. And that's what we get, which is half A minus root 3 over 2 sine A. Easy question, soft. Easy, soft. Now question 18. Question 18 says, what is the relationship between the line x squared minus 2x plus 4 and y equal to 2x? So let's look at that. X squared minus 2x plus 4. Let's have a bigger space. Y is equal to x squared minus 2x, x squared minus 2x plus 4, and y is equal to 2x. So that's it. So now that they want y is equal to these two, what we need to do is just solve them simultaneously to find what's happening. So x squared minus 2x plus 4 must be equal to 2x, because y must be equal to y. So we equate these two. And so when we bring 2x over here, we're getting x squared minus 2x, and we subtract 2x from both sides and get minus 4x plus 4 is equal to 0. That's what we get. And so we can factorize it now and equate it to 0. And what we're getting is x, 2, and 2. Signs are the same, both of them negative, so that's minus and minus. So what we're getting is x is equal to 2. So it only have one point of intersection. And if x is equal to 2, then y is going to be equal to 2 times 2, which is 4. So the point of intersection is 2, 4. That's the point of intersection. So the point of intersection is 2, 4. So it touches the curve at 2, 4. That's option B. Easy question. Question 19. It says, if P is equal to 2 sine square plus 2 cos square theta times sec square minus tan square, what is P? Now if you factor out 2 right here, sine square plus cos square is 1. And so what we end up get is 2 times, this is really 2 times sec square minus tan square. But sec square, this part right here, sec square is 1 plus tan square. That's another identity. Sec square is 1 plus tan square theta. And so 1 plus tan square theta minus tan square theta, that's just 1. And so we end up get tan square minus tan square is 1. So it works out to be 2 times 1. And 2 times 1 is just 2. Easy question. Option A. Soft. Easy. Now question 20. Question 20. All right, now option 15. Question 15. Yes, thank you. Question 15 is C. Yes, question 15 is C. Thank you. Paying attention. Very well. Thank you.
Oh, yes, sir.
Question 15 is C. That should be true. Why is it not erasing? This is the correct answer. Option C. That's the correct one. Thanks a lot. As I said, it's C over A, which is minus 7 over 3. Yes, this is it. Right. Question 20. There are two ways to do question 20. And first and foremost, I can just put this in a calculator. You don't need to work it out. So put in a calculator cosine 75 times the sine of 15. Just make sure you bracket it. Cosine 17 bracket, cosine 75 bracket, sine 15 minus bracket, sine 75 bracket, cosine 15. You put all that in a calculator, you're going to get minus 0.866. Minus 0.866 is minus root 3 over 2. You just put this in a calculator. You don't need to do nothing. Just put it in a calculator. Easy. So cal, put this in a calculator. Don't work it out. That's a waste of your time. Cal, that's a waste of your time. Let's put it in a calculator. Easy. Question 21. Question 21 goes by saying, what value of theta satisfies this equation? We did this in the last paper and we got pi by 3. Let's repeat. Soft. Easy. Question 22, it says the curves y squared equal x plus 7 and xy intersect at 3 points. What are the y coordinates? So let's solve when these 2 points intersect. We have y squared is equal to x plus 7. Let's write it down. Y squared is equal to x plus 7. And then they tell us that xy is equal to 6. First and foremost, let's read what the question said. The question said, find the y coordinate. So they don't want x, they only want what is the y coordinates. So we're going to make x the subject so we can just find the y coordinate. From this equation, we're going to get that x is equal to 6 divided by y, 6 over y. That's x. So substitute 6 over y here to get that y squared is equal to x, which is 6 over y, plus 7. So now we can multiply through this equation now by y. And so what we're going to get is, we'll multiply through by y, we're going to get y cubed is equal to 6 plus 7y. Y cubed is equal to 6 plus 7y. So bring over here now, we get y cubed minus 7y plus 6 is equal to 0. Now when you get to this part, I don't want nobody to do no long division and no factorization. First and foremost, the solutions of y are always going to be a factor of 6. And so what I want you to do is to try values of y that are factors of 6. So let's start from negative 1. Try negative 1, you get negative 1 cube minus 7 times negative 1 plus 6. So you're getting minus 1 plus 7 plus 6. That is 0. And so y equal negative 1 is true. So since negative 1 work, we can then try y equal to, let's say, negative 2. Try y equal negative 2. Why did I go negative 2 and not negative 1? Why did I go negative 1, negative 2 and not positive 2? Because when I multiply the three of them, I should get 6. Remember from cubic equation, alpha, beta, gamma is equal to 6. We just found that alpha is negative 1, so negative beta gamma is 6. And so we need beta to be negative. So I'm going to try beta as negative 2. Negative 2 cube is negative 8 plus 6, that's negative 2, minus 7 times negative 2. That's working out to be 0. And so since we have negative 1 and negative 2 working, then finally gamma must be equal to another value for y is the sense that gamma must be equal to 3. Because when you multiply them, negative 1 times negative 2 times 3 must give us 6. So that's the 3 roots. Negative 1, negative 2, and 3. That's option A. So those are the y values. And remember, we don't need to find x. We don't need to find x because I didn't want x. All right, easy. All right, this question asks for the sine of pi by 2 plus p. That's just going to be the cos of p. Let's work it out. Using the compound angle formula, we get sine pi by 2. Sine pi by 2 is 1 times the cosine of p, 1 times the cosine of p, plus the cos of pi by 2, which is 0, times the sine of p. But 0 sine p is 0, and so we just get cos p. So that's B. Easy, soft. Question 24. It says that P and Q are perpendicular, and so P dot Q is equal to 0. If P dot Q is equal to 0, then 3P minus Q is 0. 3P minus Q is equal to 0. And that's easy. That's option D. Easy. Question 25 is a repeat question from the last paper we did, and that was 2 cosec 2x. That's a repeat question. Easy. Soft. Question 26 is another repeat question from the last paper, and that was 1 over 3 and 1. Easy, soft. Question 27 is also another repeat paper question from the last paper, which we got was a half x minus 3. Easy, so they gave us 3 repeat questions in a row from 26.
Sarah number 25.
25? 25. 25 is A.
Thanks.
All right. All right, question 28 now. Question 28 says, the point P has position vector minus 3, 5, and Q is another point such that PQ is equal to 1, negative 7. Find the position vector of Q. Now, first and foremost, PQ Let's write it down. PQ is equal to OQ minus OP. OQ minus OP. And so to get OQ, which is the point Q, it's going to be equal to PQ plus OP. So PQ plus OP is going to give us OQ. That's OQ. So what we need to do is add the two vectors. So PQ is -3. That's PQ plus OP. Add these two vectors, -3 plus 1 and 5 plus -7. And that's OQ. That looks like -2, -2. That's OQ. -2, -2. Easy. Before we go to 29, I just want to look at 31. It's A. That's a repeat question. We looked at it where we use chain rules. I just want to shade that from now. That's another repeat question. Easy. Question 29. Question 29 asks for a unit vector. There's only one possible answer here. How do I know that? A unit vector represented this way, a unit vector of vector u is equal to 1 over the modulus of u times vector u itself. There's only one of them in this form, 1 over u, 1 over the modulus of u times vector u. That's B. There's only one of them in that form. And so this is a unit vector. Easy, soft. That's question 29. 31. Now question 32. Question 32 may seem a little tricky, but it's quite simple. It says find the limit of this rational function. All you're going to do is put in directly -1 in this function, and you're going to get -1 squared is -1 plus 1. Then you have 1, put in -1, so we get 1 minus x is -1, so you get -1 minus 2, and you're dividing it by -1 minus 1, which is -2. And so we get 2 minus 2 is 0 over -2, which is 0. So that's B. Question 32 is B, which is too easy, soft. That's question 32. Question 33. Question 33 is asking us for the integral of cos square x over 4 dx. Now look at this right here. They tell us that cos 2x is equal to 2 cos square x minus 1. So if I add 1 to both sides, I'm getting that cos 2x plus 1 is equal to cos square x, cos square x. That's cos square x, and then I can, that's 2 cos square x, I just divide by 2. So cos square x is equal to cos 2x plus 1 over 2, right? Now let's say I replaced x with x over 4. So I'm going to replace x with x over 4. So what I'm getting is that cos square x over 4 is equal to, right here, so now I can factor out the half, just factor out the half, and write in bracket, cos 2x now is going to be x is x over 4. 2 times x over 4 is the cosine of x over 2 plus 1. That's what we're going to get, cosine x over 2 plus 1. That doesn't look, that's not well written. cosine x over 2 plus 1. And so therefore the integral of this side is going to be equal to the integral of this side. So the integral of this side is equal to the integral of this side. Now the integral, this works out then to just be a half the integral of cosine x over 2 plus a half the integral of 1. But the integral of 1 is just x, and so it becomes a half times x. So that's the answer. A half cos x over 2 plus a half x, which is c. That's option D. Easy question.
Sir, may I get that again?
Oh, I get this?
Yes, sir.
So the first part is, so you follow from right here, where cos square x is equal to cos 2x plus 1 over 2. You agree with
May I
that,
get
right?
that first?
All right, so let's put that on a clear paper. Let's write it a little bit bigger. So agree that cos square x, you agree that cos square x is equal to cos 2x plus 1 divided by 2. Now the question had asked us something with cos square x over 4. So what we're going to do is we're going to write this as a half, cos 2x plus a half. So this can be written as a half cos 2x plus a half. Now the question wanted cos square x over 4. So we're going to write it as cos square x over 4. That's going to be equal. Replace x with x over 4. So we get a half cos of 2 times x over 4. 2 times x over 4. 2 times x over 4 plus a half. Now the cos of 2 times x over 4, this 2 right here, 2 cancels a 2 out of the 4. So it works out to be equal to now a half cosine x over 2. Half cosine x over 2 plus a half. So that's cos square x over 4. And so now the integral of cos square x over 4.
Wait, sir. You have cosine 2x.
Cosine 2x. Yes. What about cosine 2x?
Sir, wouldn't that be cosine of x over 2?
Oh, right here. Yeah, thank you. Thank you. I don't know where that come from. Thank you. That came out of nowhere. Cosine x over 2. Thank you. So it's a half cosine x over 2 plus a half. And so now the integral of cos square x over 4 is just the integral of all of this. And we know the integral of all of this can be broken up as the integral of this side plus the integral of a half. And the integral of a half is just a half x.
Times x.
And so that's how we end up get this part now. Easy, soft. And that's question 33. Easy. All right. Question 34. It
So what
asks,
is the answer?
Sorry, I missed 30.
I missed which question?
30.
Oh, question 30. Oh, I didn't see this question. So secant of beta is 1 over the cosine of beta. And so 1 over 5 over 13 is 13 over 5. So 13 over 5 looks like option D. That's option D. All right. isn't, so 33, question 33. Oh, so guys, you see this trick now, look at this. Look at the answer that I write down right here. Thank you, Tony, very good. Very good. Thank you, Tony. And very good. Now look at this, guys. I shade option C. But look at this, a half integral of cos x over 2. This doesn't have a half right here.
Oh, yes, sir. Yeah. So the answer is dog.
So you see how we can easily get the answer right and still give it away. You cannot give it away. So this is the correct option. That's the correct option. Very good, very good. Thank you, Tony. Sharp. Nice. So we have to stay sharp. They like to put what is known as a distractor, something that is the answer, but it's not the answer. Now we need to know the values of x for when the function is discontinuous. The function is discontinuous and the denominator is 0. The denominator is going to be 0 when x equals 5 and when x equals -3. So it's 5 and -3. That's clear. Because if you put 5 right here, 5 minus 5 is 0. You put -3 right here, you get 0. And so that's option A. All right, question 35. Question 35 is asking us to find the integral of f of x from 2 to 4. All right? No, it gives us the integral of f of x from 2 to 4 and asks us to evaluate this integral. Now, before we do that question, just want to clarify something. Look at this. Let's say I give you a graph, right? And this is a curve. And let's say this is the point A, this is the point B, and we have some point C. Then the integral from A to B is equal to the integral from A to C plus the integral from C to B. Very clear. So we have to know that the integral from A to C would be plus the integral from C to B gives us the integral from A to B. So likewise, this question gives us now the integral. It gives us the integral from 2 to 4 of f of x. The integral from 2 to 4 of f of x is the same as the integral from 2 to 3 of f of x plus the integral from 3 to 4 of f of x. That's the same thing. Just to point this out. All right. So now we can tackle the question. So the question wants this part. So first we have to expand this bracket inside here. And so what we're getting now is the integral from 2 to 3. I'm going to remove the f of x, but we know it's f of x we're talking about. Plus expanding this integral, we get the integral from 3 to 4 of f of x as well. Then continuing, we get minus the integral from 3 to 4 of -1. Now these two part together is just the integral from 2 to 4 of f of x. Minus, now the integral, this should just be 1, at -1.
Okay, that sounds great. Yes,
Now the integral from 3 to 4 of 1 is, when we integrate 1, we get x. And so this is now x. And we're going from 3 to 4. And the question told us that the integral from 2 to 4 of f is 12. So it is 12 minus 4 minus 3, which is 1. So 12 minus 1 is 11. So the answer is 11. Easy. Soft. Question 36. Question 36 asks, what is the value of p for when the function is continuous? So only thing we need to do is put in g of 3, and g of 3 is going to be equal for both the left-hand limit and the right-hand limit. So that is, we just need to work out 3 times 3 plus 5. 3 times 3 plus 5 is equal to 5p plus 2. Wait, where I get 5 from? 3p, x is 3. 3p plus 2. And so what we're getting is we bring the 2 over here, we get 12 is equal to 3p. And so clearly p must be equal to 4. P must be 4. That's C. Easy. All right. Now question 37. Question 37 is asking us to find a curve as equation y equal to 16x plus 1 over x, and it wants to find the stationary point of the curve. To find the stationary point, we need to differentiate y, and so we need to find dy by dx. So dy by dx is equal to, we differentiate 16x to get 16, or differentiate 1 over x to get minus 1 over x squared. Because we can rewrite 1 over x as x to the minus 1. And to find the stationary point, we solve dy by dx being equal to 0. And so what we're solving is pretty much 16 is equal to 1 over x squared. If we're solving 16 is equal to 1 over x squared, transposing for x squared, we get x squared is equal to 1 over 16. When you take the square root of both sides, you get x is going to be equal to plus or minus the square root of 1 is 1, the square root of 16 is 4. So it's plus or minus 1 over 4. So that's the stationary point. Easy question, soft, with a capital T. That's C. No, that's D. Plus or minus 1 over 4. Question 38. It says we have, if the rate of change of y with respect to x is this. So they're giving you dy by dx. So they said dy by dx is equal to, we have that it's equal to 3x squared plus 4x cubed. But I'm going to write 4x cubed as 4x to the minus 3. That's 4x cubed. And so y is equal to add 1 to the power, divide by the power, 3x cubed divided by 3, plus add 1 to the power, so I get 4x to the minus 2, divide by the power of minus 2. So what I'm getting is just x cubed. 4 over minus 2 is just minus 2, so I'm getting minus 2. Then x to the minus 2 is over x squared. And remember, when we integrate, we get some constant, so I just put plus k, plus some constant k. It looks like option C. Easy question, soft. Question 39. It asks us, where is the function discontinuous? So this is a repeat from the last paper. And we said that the function is discontinuous anywhere where the denominator is equal to 0. So in the last one, when x is equal to -1, then the function is undefined, and so D, option D is the answer. Easy question. Question 40. Question 40 asks us to find f of x when f prime of x is sine x. If f prime of x is sine x, when you integrate sine x, you get f of x. So notice now, when you integrate sine x, you get minus cos x. When you integrate sine x, you get minus cos x plus some constant. That looks like option A. Easy, soft, the capital T. Question 41 now. All right, question 41. All right, question 41. So for question 41, we're going to use quotient rule. No, let's use product rule. So we have y is equal to 2x plus 1. Y is equal to 2x plus 1. The square root is really to the half power. So that's really to the half power. And so dy dx is equal to carry down the power, subtract 1 from the power, times the differential inside the bracket. Subtract 1 from the power to get minus half, times the differential inside the bracket, which is 2. Now this 2 cancels the half, and so dy by dx is really just equal to 2x plus 1 to the minus half. That's dy by dx. Dy by dx is 2x plus 1 to the minus half. That's dy by dx. So now we need to find d2y by dx squared. The d2y by dx squared, that's what they actually want. It's equal to bring down the power, get minus a half, subtract 1 from the power, we get 2x plus 1 to the minus half minus half minus 1 is minus 3 over 2 times the differential inside the bracket, which is 2. This 2 right here cancels the half. And so we're left back with d2y by dx squared is equal to minus 1 over, this can be written now as 2x plus 1 to the 3 over 2 power. But to the 3 over 2 power, so to the 3 over 2 power. Now look how I'm going to break up to the 3 over 2 power. So the 3 over 2 power can be written as minus 1 over, this can then be written as 2x plus 1 to the half power times 2x plus 1 to the 1 power. Because by laws of indices, when the bases are same, we can add the power to get 3 over 2. So 2x plus 1 to the half power is the square root of 2x plus 1. And 2x plus 1 to the 1 power is just 2x plus 1. That's option B. And that's too easy, soft. That's option 41. Option 42 is a repeat question from last year. And we looked at that already and we said option B was not true. That's a repeat question. Option 44 is also a repeat question from last year. And we said the option was A. So those are 2 more repeat questions. All right. Question 43. Question 43 says, Find the area of the diagram below. Now the area, now look at this. Area is always positive, right? Let's say I give you a square. Just want to show you something. If I give you a square with length 4, right? Then the area is going to be equal to, the area is equal to 16. But look at this. Let's say I put this square on a graph. I put this area on a graph and I put it completely below the x-axis, right? And so now it has a length of -4, length of -4. But because it's completely below the x-axis, the area is going to work out to be negative. Area is going to work out to negative, all right? And so in this case, when it's completely below the x-axis, I'm going to be getting area is -16. But that's not true. The area is actually the modulus of -16, which is just 16. All right? That's because when something is below the x-axis, it's going to be negative. That's what happened. So let me give you a practical example. Let's say I ask you to find now, let's say I give you a curve. Which curve goes below the x-axis? Let's say I ask you to use a line, y is equal to 3 minus x. Y is equal to 3 minus x. Y is equal to 3 minus x. That's a line like this. Passes through the point 3 and 3. Let's say I want to stop at when x is 5. If I ask you to find the integral for this line from 3 to 5, it's going to be negative. The integral from 3 to 5 of 3 minus x, right? So look at the triangle that we get from 3 to 5. This is the area that we want, the area of the triangle, right? Before we use integration, the area of the triangle would be half base times height. Half of the base, which be the base would be 2, half of 2 times the height, right? Times the height. The height corresponds to whatever y value this is when x is 5. When x is 5, we get 3 minus 5, which is -2. And so the height is actually 2. So this is actually a height of 2. And so we're getting a half of 2 times 2, which is a half of 4, which is 2. So the area of the triangle should be 2. Now we're going to use integration and look what the area is going to give us. Using integration, we add 1 to the power, we get 3x minus, add 1 to the power, divide by the power. We're integrating from 3 to 5. So we'll plug in 5. What we're getting is 3 times 5 is 15 minus 5 squared is 25. So we get minus 25 over 2. Close bracket minus, put in 3 now, we're getting 9 minus, plug in the 3. In here we get 3 squared is 9. 9 over 2. All right, so if you put this in a calculator, 15 minus 25 over 2, 15 minus 25 over 2, what we're getting is 2.5 right there. That part works out to be 5 over 2 minus, now 9 minus 9 over 2, 9 minus 9 over 2 is 4.5. So that works out to be 5 over 2 minus 9 over 2, which is equal to -2. Notice that when we integrate, we get negative when it's below the x-axis. And so in order to get the area, which needs to be positive, it would have to be the modulus from 3 to 5, the integral of the modulus from 3 to 5. That would give us the actual area of 2. So then, how does all of this that I'm saying relates to this question? What I'm then saying is that the integral from this part, from 1 to 3, we need to take the modulus of it to get the area. And so the total area shaded, let's call it A, is equal to the integral from 0 to 1 plus the modulus of the integral from 1 to 3. It has to be the modulus because area below x-axis is going to be negative. So that's option D. Easy question. Soft. All right. Question 45. All right, now this is not a repeat question. The last question we looked at last time asked us for the volume around y-axis. Now they got to ask volume around x-axis. Volume around x-axis is pi times the integral of y squared dx. Y squared dx. And it told us that we're integrating from 0 to 2. So it's equal to pi times the integral from 0 to 2 of y squared, but let's make y squared the subject. Y squared is equal to 4 minus x squared. So it's equal to 4 minus x squared dx. Pi times the integral of 4 minus x squared dx. Oh no, where did that go? Erased it. My bad. Here it is. So that's pi times the integral of 4 minus x squared dx. That is option B. Easy question. Easy. Soft. All right, easy. So that's it. So we've completed 2016 and 2017 paper. And so I'm going to send everyone. So anybody that hasn't sent me their email, you can send me an email in the chat, in the Zoom chat right here, so that I can email to you the 2016 and the 2017 paper, as well as the working out answers. I'll email the working out answers with the papers. All right. And so next week, all right, thank you for the emails. So next week at this time, so next week, we'll be going through 2018 and 2019 paper. All right. So that's what we'll be doing. We'll be going through 2018 and 2019 paper. All right, so. Okay. All right, so for the persons that wish to know their IA grades, I'm going to send you your IA grade. Send it to your email. For some reason, I don't know why my chat not going through. All right, thank you, Marva. All right, so everyone, enjoy the rest of the evening and keep on practicing. All the best with the rest of the exam for the week, and always do some mathematics. All right, always do some mathematics.
Thank you, sir.
All right, so I'll hear from you all next week, and good luck with your exams this week.
Yes,